Hello, chemists. We are going to continue our journey for this week on intermolecular forces. And so this concept of intermolecular forces has a lot to do with that heat of fusion we talked about in our last video and the heat of vaporization. Okay. It has a lot to do with how DNA particles stick together and are easily unzipped when DNA replication happens. It is also an explanation for why saturated fats are solids at room temperature, right? So we have this chemical concept of how these particles are sticky. Saturated fats are solid at room temperature. So all of these concepts right here can be described and explained in a chemical way when we talk about this thing called intermolecular forces. So before we get started, I just want to make sure that we are clear. I'm going to kind of review just a bit. We're clear that bonding, right, comes in two flavors, right? We get ionic bonds, and those are between metals and a non-metal, and the electron is actually transferred. We get covalent bonds, and those are between two nonmetals. And we have two flavors of those bonds. We have polar bonds and we have nonpolar bonds, and that's dependent on equal sharing of electrons versus unequal. Okay, so what I want to make sure we understand is when we talk about bonding, this is within. So basically we have, an ionic bond like sodium chloride, right? The electron's transferred. We have this bond that exists between the atoms. We have our favorite covalent compound, that's water, and we know that water is bent. We know it's got two lone pairs, and we know that this bond right here is a polar bond because the oxygen is pulling the electrons away from it. And we know that there's an unequal distribution of electrons. There's electrons hanging out here, and this is making this side negative and this side positive. And so we kind of know that. And the idea is when we talk about bonding, we're talking about between atoms within a molecule. Okay, so that's the idea. When we talk about, those are intermolecular forces. Intermolecular forces. Well, let me try that again. I just said that wrong. Intramolecular forces. They are within the molecule. Or within. So that's inside the molecule, right? So we are going to talk about intermolecular forces. So we are going to talk about intermolecular forces. Okay, and those are between molecules. And basically those are the things that affect the things I mentioned earlier. And those things I mentioned earlier again are, why is it a specific amount of energy to make something freeze or boil? How is DNA stuck together? And how come saturated fats are solid at room temperatures? Okay. So I'm going to skip this part right here because we just kind of went over phase changes and how they're different from chemical changes. So we'll just kind of assume you guys are there. I want to kind of just jump into this, what would cause melting and boiling points for substances to be different. We know for water, maybe, the melting point of water is 0 degrees Celsius. We know that's also the freezing point. We also know the boiling point or the condensation point of water is 100 degrees Celsius when it's pure, right? That's not true for every substance. Different substances have different melting points, and those melting points are dependent upon these intermolecular forces. So what I want you to think about is when we drew that diagram of the change in phase for water, right? We did the temperature on this axis and the heat on this axis, and we talked about this phase change right here and this phase change right here. This is our melting point and our boiling point. We know that for water, there was 80 calories per gram involved in this phase change, and there was 540 calories per gram included in this phase change. So we want to try to account for what that is, right? And so essentially when we think about what a solid, a liquid, and a gas look like, we know that in order to go through that phase change, we have to separate the particles. And so the intermolecular forces, these forces that exist between the particles, that's what we have to overcome when we melt or we boil something, okay? That's what we have to overcome when we have to melt or boil something. So that's our idea about melting and boiling point. And then we talked a little bit about vapor pressure. So in the last video, we talked about how you can have a container and we can stopper that container. And in that container, we can put its liquid. And in this case, we talked about water. So we have water liquid here. And above that liquid is the gaseous version of that substance. And it is exerting pressure on the walls of the container, right? So basically, if we understand this concept of intermolecular forces, we know that we have to separate the particles that are in the liquid form, right? They have to, in order to go into gaseous form, we have to separate them, and we have to overcome the sort of stickiness. So we have to overcome the IMFs, we call them IMFs, the intermolecular forces, to vaporize, basically. And that's dependent on how sticky the particles are with one another. Okay, and then the third concept that you may not be aware of is surface tension. Surface tension is this idea, and you've seen it in lab, where when we put water into a graduated cylinder, right, that water actually creates what we call the meniscus, right? So that meniscus right there. And this is a manifestation of surface tension, right? So this meniscus is a combination of the water wanting to adhere to the glass, but also adhering to itself. Okay, you may have seen this maybe in an example of something you might have done in elementary school, where you took a penny and you dropped water on it, and you were able to see that you could actually build this big dome of water up. It's kind of surprising, because all the water is sort of attracted to itself. So this is surface tension. The other place you might have seen this is if you've ever seen one of those little water beetles that actually has a little sort of legs that's on water, and basically it's kind of standing on the water, and you can see that it's taking advantage of the surface tension. And lastly, perhaps you've tried to sort of float like a needle on water. So basically you can get a needle to float on the water, because if you carefully put it on there, there's like this sort of skin over the water that's created by the attraction the particles have for each other. Okay, so we have three sort of properties of matter. We have the boiling point or the melting point, we have the vapor pressure, and we have this concept of surface tension, okay? And we can explain all of these properties by the intermolecular forces that exist between the particles. And so in the next video, we'll talk about that.